Okay, students, last class we discussed the conversion of a square matrix into the sum of a symmetric and skew symmetric matrix. The meaning is we discussed how to express a square matrix as the sum of a symmetric and a skew symmetric matrix. Okay, and today we just do an example for the conversion. So express A equal to matrix 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3, okay, as the sum of a symmetric and a skew symmetric matrix. Okay, so we said the symmetric part we named it as P, okay, is equal to half into A plus A transpose. Skew symmetric part, okay, we have taken it as Q, that is equal to half into A minus A transpose. Okay, therefore P is equal to half into matrix A, that is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3 plus A transpose. So transpose means the matrix obtained by converting the rows into columns. So the first row 6 minus 2 2 becomes the first column, minus 2 3 minus 1 2 minus 1 3. Okay, is equal to half into, adding the matrices 12 minus 4 4 minus 4 6 minus 2 4 minus 2 6. Okay, then thereafter multiplying by 1 by 2 means dividing by 2. So 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, then Q equal to half into A minus A transpose. Okay, is equal to half into matrix 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, minus A transpose means we can say this is going to be minus. Okay. Actually, here the speciality of the given matrix is, see, the first row is 6 minus 2, 2. The first column is also 6 minus 2, 2. The meaning is actually A transpose and A are equal, and so the matrix A is symmetric. Okay, but anyhow, we are just concentrating on how to express matrix A as the sum of a symmetric and a skew symmetric matrix. So here actually, since A and A transpose are equal, by default this A minus A transpose is going to be the zero matrix. Actually it's happening only because of the peculiarity of the matrix A. So it comes as half into, all the elements are going to be 0. Okay, is equal to matrix. Okay, therefore, now A equal to P plus Q. So A equal to matrix P means that is 6 minus 2, 2. 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Okay, plus Q means the zero matrix, 0, 0, 0. So, for the matrix A, the symmetric part is A itself, but the skew symmetric part is zero matrix. Okay, so what we have to make out here is, if the given matrix itself is symmetric, then while expressing the matrix as the sum of a symmetric and skew symmetric matrix, the skew symmetric part is going to be a zero matrix. Clear? So what we said, when the given matrix is a symmetric matrix, while expressing the matrix as the sum of a symmetric and skew symmetric matrix, the symmetric part is the matrix itself and the skew symmetric part is the zero matrix. Okay, now we discuss one more example, because actually, as we said here, by default the skew symmetric part became 0. Okay, so we come to 3.3 exercise. We have done question. The last question was question number 10, second part. Now we do question number 10, part 3. Okay, we take A equal to matrix 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. Okay? Then symmetric part. We name as P, that is equal to half into A plus A transpose. Okay, that is equal to half into 3, 3 minus 1 minus 2 minus 2, 1 minus 4 minus 5, 2. Okay, plus A transpose. The matrix obtained by writing the first row as the first column, minus 2 minus 2, 1 minus 4 minus 5, 2 equal to half into 6, 1 minus 5, 1 minus 4 minus 4 minus 5 okay minus 5, then minus 4, 4. Okay, skew symmetric part. Okay, is equal to we name it as which one? Q is equal to half into A minus A transpose. Okay, is equal to half into okay A, that is 3, 3 minus 1 minus 2 minus 2, 1 minus 4 minus 5, 2 minus matrix 3 minus 2 minus 4 3 minus 2 minus 5 minus 1 1. Okay, then subtraction means the negative addition, or simply do the subtraction. Okay, 3 minus 3, 0. Okay, 3 plus 2, 5. Then minus 1 plus 4, that is 3. Minus 2 minus 3, that is minus 5. Minus 2 plus 2, 0. Because we know in a skew symmetric matrix, all the principal diagonal elements are going to be 0. Okay, 1 plus 5, that is 6. Then minus 4 plus 1, that is minus 3. Minus 5 minus 1, that is minus 6, and 2 minus 2, 0. Okay, and here also then multiplying by 1 by 2 means dividing by 2. So 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. Okay, and in the symmetry part also, that is P is equal to half into A plus A transpose. So there also we do the multiplication by 1 by 2. Okay, means division by 2. So 6 by 2, 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2 minus 2 minus 5 by 2 minus 2 okay, so 3 1 by 2 minus 5 by 2 1 by 2 minus 2 minus 2 okay, minus 5 by 2 minus 2 okay, so thereafter we can say what will come. Therefore A is equal to P plus Q. Okay, so this is the expression for A, means the square matrix A as the sum of a symmetric matrix and a skew symmetric matrix. So the last two questions we have seen, when a matrix A is given, it can be expressed as the sum of a symmetric and skew symmetric matrix as A equal to P plus Q, where P is the symmetric part and P is equal to half into A plus A transpose. Q is the skew symmetric part and Q is equal to half into A minus A transpose. Okay. Okay, now we just come to a simple question, that is question number 12. Actually, it is an application of trigonometry. If A equal to matrix cos alpha minus sin alpha cos alpha, okay, and A plus A transpose is equal to identity matrix I, then find alpha. Okay, so here A equal to matrix cos alpha minus sin alpha cos alpha, and A plus A transpose is equal to I. So we have to obtain the value of alpha. Okay, so what is when you come to the answer, here A plus A transpose is equal to I. Therefore, matrix cos alpha minus sin alpha cos alpha plus, okay, A transpose. So first row becomes the first column, second row becomes the second column, okay, is equal to I. Therefore, okay, cos alpha plus cos alpha, that is 2 cos alpha minus sin alpha plus sin alpha, that is 0, sin alpha plus minus sin alpha, that is again 0, then 2 cos alpha, okay, is equal to I. Okay, we know that I is the unit matrix or identity matrix, and we said depending on the requirement, the identity matrix I can be taken as I2, I3, etc. Okay, and here matrix A is of order 2. So in our discussion, I stands for I2, that is identity matrix or unit matrix of order 2. Okay, so I can be written as matrix 1, 0, 0. Okay. Now here we reach to the equality of two matrices. Okay, and we know that two matrices are equal only when their orders are same. Yes, the matrices are of order 2 by 2 and the corresponding elements are equal. Okay, so we equate the corresponding elements. Actually 2 cos alpha is 1. Okay, 0 is 0. Okay, so anyhow it is enough to consider only one equation because we have only one unknown, that is cos alpha. So we are getting therefore 2 cos alpha is equal to 1. So cos alpha is equal to 1 by 2. Okay, and cos alpha 1 by 2. The meaning is alpha for how much angle cos is 1 by 2. For how much angle cos is 1 by 2? 60 degree, that is pi by 3. So alpha equal to pi by 3. Clear? Okay, so cos alpha is here A is given and the condition given is A plus A transpose equal to I. Applying the condition, okay, and taking I as identity matrix of order 2, and we come to which one? Cos alpha is equal to 1 by 2 and correspondingly alpha is equal to pi by 3. Clear? Okay, so related to transpose, okay, this much is enough. Okay, now we come to new concept, okay, and it is one of the most important concepts related to matrices. That is, we come to inverse of a matrix. Okay, we come to inverse of a matrix. Okay, so actually the concept of inverse. Okay, so when we study function, then we study about inverse of a function, and actually that we have discussed in the very first chapter, relations and functions, and thereafter in chapter number 2 we study about inverse trigonometric functions. For example, we come to the sine function, and the inverse of sine function is the inverse trigonometric function, namely sine inverse. Okay, so in the same manner we come to inverse of a matrix. Okay, so when we come to inverse of a matrix, we simply come to the definition. Okay, for a given matrix A is a given matrix. If there exists another matrix B such that the product AB and BA both exist and AB is equal to BA, both are is equal to the identity matrix I. Clear? So what we said, for a given matrix A, if there exists another matrix B such that product AB and BA both equal to the identity matrix or the unit matrix I, okay, then B is known as B is known as the inverse of A. Okay, so if AB is equal to I equal to BA, then B is known as the inverse of A. Okay, and of course B is the inverse of A. Okay, therefore vice versa, that is A is inverse of B. Okay, it means A and B are, we can say which one, A and B are inverses of each other. A and B are inverses of each other. Okay, then what we said here, B is the inverse of A, and usually inverse of A is denoted by the symbol. Okay, we write it as A raised to minus 1. Okay, and we read it as what? A inverse. So inverse of A is equal to A inverse. Okay, so here the meaning is what? So according to our definition, B is the inverse of A. The meaning is what? Here B is nothing but A inverse. Okay, so we can rewrite the condition AB equal to BA equal to I as A into A inverse. That is identity matrix I, A inverse into A. That is also what? The identity matrix I. Okay, and if the inverse of a matrix exists, so what we say, if A inverse exists, then we can say then A is said to be an A is said to be an invertible matrix. What we say? A is said to be an invertible matrix. So this topic, either we can say we come to the discussion of inverse of a matrix, or we can say invertible matrices. So when we say a matrix is invertible, when its inverse exists. Okay, and what is the definition of inverse? So what we said, for a given matrix A, okay, if there exists another matrix B such that AB equal to I equal to BA, then B is known as the inverse of A and vice versa. Otherwise we can say which one? A and B are inverses of each other. Okay, and usually inverse of A is denoted by A raised to minus 1, and we read it as A inverse. Okay, since A inverse is the inverse of A, we can say A into A inverse is equal to I is equal to A inverse into A. Okay, and again we said, if the inverse of a matrix exists, then that matrix is known as an invertible matrix. Okay, it is invertible. Okay, the meaning is it is possible to obtain the inverse of the matrix, otherwise the inverse of the matrix exists. Okay, now, so the most important property we have noticed is what? The product of a matrix A and its inverse A inverse is equal to identity matrix, and in the reverse order also A inverse into A. Okay, now, so when we say in general, okay, the inverse of a matrix may or may not exist. Okay, the inverse of a matrix may or may not exist. So it means it is not necessary that the inverse of all the matrices exists. Okay, that is why in the very definition itself, what we said, for a given matrix A, if there exists a matrix B. So not necessary if B is there such that product AB and BA equal to I, what we say, A is invertible and the inverse of A is B. Okay, so anyhow what we said, it is not necessary that the inverse of a matrix exists. Okay, but if the inverse exists, then what we say, inverse, if the inverse x, if the, so what we say is, if the inverse of a matrix exists, then inverse is unique. What does it mean? The inverse is unique. What is the meaning of unique? One and only one. The meaning is what? If the inverse of a matrix exists, it is unique. The meaning is what? It has only one inverse. Okay. So now thereafter we have to come to the calculation, okay, or the determination of inverse of a matrix. Okay, then for that, okay, there are different methods. Okay, and now actually the concept of matrix is given in two different chapters. Okay, chapter number 3, what we are discussing is the matrices, and in the next chapter, okay, after studying determinants, as a second part of the chapter, we come back to which one? Matrices again. Okay, and there we discuss the determination of inverse of a matrix by another method. Actually, we simply call it as by the method of adjoint. Okay, but here this chapter we determine the inverse of a matrix by elementary transformation. By elementary transformation. Okay, in elementary transformation, okay, there are two types of elementary transformation. Okay, one is elementary row transformation. Okay, and second is, of course, what will come? Elementary column transformation. Okay, that we discuss in the next class. Okay, how to obtain the inverse of a matrix by elementary row transformation, okay, and elementary column transformation. Okay, so just before winding up, we recollect what we discussed today. Okay, first of all, we discuss how to convert or how to express a square matrix as the sum of a symmetric and a skew symmetric matrix. Clear? Okay, and thereafter we have discussed the concept inverse of a matrix. Okay, and we said we come to the determination of inverse of a matrix, and for that we discuss two methods. Okay, generally the method is known as what? Elementary transformation, and the elementary transformation we come to which one? Elementary row transformation, and elementary column transformation. Okay, so that we discuss in the next class. Okay, till then, bye.